booming self yet, but it'll get there. All right, so proving triangles similar. So 3 different ways to do that. Angle, angle, side, 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 and then side, angle, side. So a little bit different with this than with congruence. Uh, Similarity and congruence are, yeah, since we have 2 of those that are the same name, we've got to be careful about what we're doing there. So notice the notation there beside of it, that it's angle, angle, and then the similarity symbol there. So that when you're doing that, writing that on a proof, write the similarity symbol beside it, just so we know that's what's going on there. So for angle, angle, if 2 corresponding angles are congruent, then the triangles are similar. You just need 2 corresponding angles to be congruent to one another. We would automatically get the third angle to be congruent because we know all 3 angles add up to be 180, right? So if this is 75 and 31, then that one's got to be whatever's left over. This one's 75 and 31. That's got to be the same amount left over because it's going to add to be 180 no matter what. So we really only need 2 angles there. So these 2 triangles on number 1 there, triangle ABC, angle A relates or corresponds to angle D. Angle C corresponds to angle F. So those would be similar. And the similarity statement, triangle ABC, is similar to triangle DEF through angle, angle. So just 2 congruent angles is all we need, corresponding congruent angles. Number 2 there, underneath there, you've got kind of that bow tie picture going on. Would these 2 triangles in this picture be similar to one another? Yes. How? Yeah, you got vertical angles right here, so that we get 2 corresponding angles. So these are, and let's get the similarity statement for that. So let's name the big triangle first. Triangle VWX. If we name it in that order, then we need to name the other one in the correct order so that the similarity is right. YZX. All right. I thought I heard YZZX. And I don't know ZZ. Is it all right? So we did. All right. Okay. VWX. So our corresponding angles are V and X. So this one would be Y and then Z and then X because we need the corresponding angles to be at the ends of our statement there. So Y, Z, X would be our similarity statement for that. Okay. So 2 angles congruent or corresponding angles congruent, you can get triangles similar. So that's probably the easiest way to do it if you've got stuff about angles. But side, side, side says we don't have anything about angles. We don't know what the angle measurements are. So we want to do side, side, side similarity. Side, side, side congruence was that you had corresponding sides that were congruent to one another. With side, side, side similarity, your corresponding sides are proportional. Then the triangles are similar out of that. So when we look at this one, we've got to have 3 pairs of corresponding sides that all have the same ratio or same proportion to that. So when we look at these 2 triangles here, side QP is 3, and if it related to TS, that'd be 3/6, which reduces to be 1/2. And if I say side PR is 4 and US is 8, that's 1/2 as well, right? And the other side pair is 5/10, which is 1/2. All of those corresponding sides there have the same ratio. They're proportional. So that means that these 2 triangles are similar by side, side, side. So let's get a similarity statement. I'm going to go PQR. So how do I have to do this one? STU. Remember, your sides They're corresponding, have to match up in your similarity statements. That's the kicker. You guys have gotten better at that. We had struggled with that at the beginning of congruence. So let's look at number 4 there. Same idea. We've got triangle CDE, and does that correspond to triangle FGH or any other configuration of that? So I always start with the smallest side. So smallest side of this triangle is 30. So that should correspond to the smallest side of the other triangle, right? So it'd be 30 and 24. So 30 over 24 reduces to be what? 5 over 4. If you did it the other way, it's still going to be okay. If you did 24 over 30, as long as you do your ratios the same every time. I started with the bigger triangle here just because it was on the left. It really doesn't matter which way you do that. So 5 over 4 is the ratio we're looking for. So then I'm going to go to the next largest side, just trying to make a systematic way of doing this. So 32 should relate to 25, right? But it doesn't reduce to be 5 over 4, right? So are these similar triangles? No, these are not similar. Because that does not equal 5 over 4. Okay. I kind of threw one in there on us that wasn't similar because of the side stuff. Have to have that same ratio. If they are not the same ratio, if all 3 pairs are not the same ratio, then we are not similar by side. Okay. So not too difficult here. It's just you got to look at ratios. Side angle, side similarity. You've got 2 corresponding sides, and then the included angle. That means the angle between those 2 sides that's congruent. So the proportional sides and a congruent angle, then the triangles are similar. So when we look at these 2 triangles there on number 5, decide if it's or if they're similar by side angle side. So we just look at where the angle is that they tell us that's congruent, and then we do our proportional sides from there. So if I did 8 over 6, that reduces to be 4 over 3, right? Is 20 over 15 the same ratio? Yeah, it reduces to be 4 over 3 as well. So we get side angle side similarity. So this is yes. And let's get a similarity statement for that. I'm going to do alphabetical order, J, K, L. Similar to M, N, P. Matches up. Goes through the short side, the congruent angle, and then the other. So that works out nice. Example 6 there. Same idea. We've got a triangle inside of a triangle. So you got to be careful about this one. We want to decide if these 2 triangles are similar by side angle side. Where is the congruent angle at? Hey, yeah, this one right here is congruent to itself. So like if you were doing a proof, it'd be like a reflexive property out of that. So so our side proportions that we're going to check, side AE should correspond to what side? 21. So 12 over 21 reduces 4 over 7. And then the other proportion we need to check would be 15 over 25, which is not 4 over 7. So these are not similar. Because that ratio is not the same. Real simple idea of checking similarity based on that. Okay. All right, let's look at the stapled together packet and get through a few of these, and then we'll get into the proofs. I know y'all are excited for the proofs. Me too. All right. Let's look at example 1 there. Got some parallel lines there. We know that by the notation that's going on there. and determine whether the triangles are similar by angle similarity. That's what we're trying to use here. We're just using angle on these, and then we're going to tell what angles they are. If you know what angles are congruent here.
You can do DF because they are alternate interior angles.
Okay, so that angle is congruent to that angle. Yeah, so this one is congruent to that one through vertical angles. So that gives us two angles in a row, which would give us similarity. Technically, we also have that third angle up here. They're alternate interior as well through a different transversal. It doesn't matter which pair you use for the alternate interiors there. You only need two. The thing about similarity is the angles are all, if they are similar, all three corresponding angle pairs are congruent to one another anyway. So with this one, you could pick whichever pair you needed to go that. So this is a yes. Let's write a similarity statement. You said DCE, not congruent, but similar. FGE. Good job. Yeah. We did so much with congruence earlier, it's hard to break their habit. All right. Number two, this is that weird, those triangle inside of a triangle pictures that can sometimes confuse us. Say again. Well, angle P has more than one angle coming out of it, so let's be more descriptive. There are two different angles there at P. So which one are you talking about? Okay. LPQ and LNM are corresponding, so they're congruent because of the parallel lines there. That's true. Okay. L is congruent to itself. So that's two angles. That's all we need. We could get the other angles. If you didn't want to use L, you could have angle LQP is congruent to angle LMN because they're corresponding as well. It doesn't matter which two you get, just get two and you get the similarity. So let's get the similarity statement for that one. LPQ similar to what? Say that last one again. LN. Good job. That'll work. Easy stuff, right? All right, let's look at number 3. What do we know about those triangles? They're right triangles. So we know that the 90-degree angles are the same already. But they give us that angle W is 51 and angle E is 39. Those are not the same. Okay, yeah, because we know triangles all equal 180. We know that this angle right here has got to be 51 as well, right? Just 90 plus 39 and subtract that from 180. And we get that going on. And we also know that this one's got to be 39. Doesn't matter which one. You only need one of those because you already have the right angle that's congruent to one another. So you only really need one of those. Just pick whichever one you want if you're doing a proof. So these are similar. Let's get a similarity statement. Not congruent, but similar. Yeah, CHW. Good job. That works. All right. Easy enough. What about number 4? You got a 68 and a 54, and here we got another 68 and a 63. Why are they not?
It doesn't equal 180.
Doesn't equal 180. This one would have to be how much to be the right thing? Yeah. 122, be 58, wouldn't it? And then this one is how much? 63, 68 be 120 plus 1131, so 49. That definitely cannot be similar because they don't have all of it. We don't have two of them that match up. So easy stuff. What about number 5? Notice on the original picture, this one is not the same as the picture on number 2.
Doesn't 91 and something else have to equal 180 because they're wait, the other side of the city, 91 have to equal 89.
Doesn't angle L equal angle B?
Does that angle L equal angle B? We'll get to what you said in a second. How do you know that? Tell me how you got there.
91 plus 67 is 158.
Okay. All right, so that'd be 22. And then, so now that tells us enough. We got one angle that's not the same in this triangle from this triangle, right? That's enough
I
to
thought
say.
that one had to have 4 angles in
It does, but we're looking for triangle similarity, right?
it.
So if we found this other angle, 67 and 25 had to be what, 92? And then so that leaves what, 88 right there. Notice that that's not 80, that should be 88 right there if they're similar. They're not similar. What notation is not on these two lines right here? The parallel notation there. That parallel not being there is key to those not being similar triangles. So these are not similar for a lot of reasons. It all relates back to that those lines are not parallel to one another. I can't eyeball the difference in 25 degrees and 22 degrees most of the time. That's very, very small amount of difference. So it's hard to tell. And that being 91, that almost looks exactly the same. So don't always just go by the picture. They look parallel when you just glance at it, but go by the numbers and look at those angle relationships there. And that's how all that's going to build up there. What about number 6? That bow tie shape again. Yeah, we got some vertical angles in the center there. So we got 2 pairs. Yeah. So this is yes. Let's get a similarity statement. ZXY. Good job. That'll work. Not bad. Pretty easy thing there. Don't need the parallel markers on that to get that to happen. Just so happens they are. End up PQ and YZ are parallel if you had to prove that going on. All right, so try to use some side stuff here. So they give us enough information about the sides that we should be able to determine if these are similar by side. So let's set up our ratios. What's the NK, the side NK, what does it correspond to? DE. So the smallest side should correspond to the smallest side. Does that reduce? No. Okay. So let's get the next smallest side. So that'd be NR corresponds to SE. So it's 13.5 over 21 the same. No. I'm going to check it and see. I believe they are. I believe they are.
You make it like 27 or 21 or 22.
Yeah, I mean, you could make it into a whole, and double it and get rid of the decimal. Yeah, that would work. This is how I'm going to check it. 9 over 14 is that ratio. 13.5 over 21. The exact same ratio. That also works. So Logan said, could you not double that fraction, the 13.5 over 21, to get rid of the decimal and make it 27 over 42, and then that would reduce to 9 over 14. that works. I'm just looking at the decimal equivalent of that because it's just a ratio that we're checking there. So those are equal to each other. We got to check the third pair though. So 20.25 over 31.5. So those are the same. Let's check that one. 20.25 over 31.5. And we do get the exact same decimal equivalent. So those are similar. So it's yes. And let's get a similarity statement. It doesn't matter which one you start with. Just pick your way of going it.
KNR similar to DES.
KNR and then DES. Yeah, good. Works. Good job. What about number 8 there? So we got that triangle in a triangle thing. So we need to check our pairs of sides. So the smaller triangle is that WXV. So I'm going to look at side WX. And it corresponds to what side?
You add 15 with 6, you get 21.
So 15 over 21 is the ratio I'm checking, right? And that reduces to be 5/7. And then we'll go down the other side of that triangle there. So WB and WU, so they 20 over 28. That reduces to be the right thing. We're good there. And then the last one would be 30 over 42. Yeah, get all the same. It's a big yes. And let's get a similarity statement. WXV, similar to what? Yeah, W. Again, that's not the only similarity statement you can do, but it'll work. All right. Hit up number 9 there. Check your ratios, 5 and 4, and then 16 and 10. Are they the same? No. 5 over 4 does not equal 16 over 10. Not similar. All right, and then number 10, try that one. Are those similar? A little bit of a strange orientation there, but again, corresponding sides. 5 over 18 or 18 over 5, whichever way you want to do that. I always start with the smallest sides. That doesn't reduce any. And 12 over 43.2. And anytime they got decimals in there, I'm just going to crank that out. And is that the same as 5 over 18? Yes, it is. So I just got to check the last pair. 15 over 54. Does that equal the right thing? Boom, it does. Check, check, check. Yes, they're similar. Now let's get that similarity statement. APR similar to, which one is it? I heard 2 different T. Should be T, because AP corresponds to TY, and then R is going to be Y. You got to have your corresponding sides lining up in your similarity statement there. Careful of that. Right triangle stuff there, fun times. Why would you need to do that?
Because we need to find the hypotenuse of the right triangle on the right side.
Okay, so we need this other side here so that we can check the proportion. We also need this leg on this right triangle. So we've got to employ that right triangle stuff that we know, the a squared plus b squared equals c squared things. So you guys do the big triangle and I'll do the smaller one. That side is, I got mine to be 12 over there. You got 81 plus 21.6 squared. Take the square root of that. 23.4. And now we can check our ratios. 5 over 9, 12 over 21.6, and then 13 over 23.4. Do they all equal the same thing? Work that out. I know what 5 over 9 is. It's 0.5 repeating. So 12 over 21.6, 0.5 repeating, 13 over 23.4, 0.5 repeating. They all are the same there. Check, check, check. Yes. And similarity statement.
Line C, triangle line C is similar to triangle WXV, WRD.
You get it. YXZ. So you would have to do WVR. That's what you would have to do it. Should be WVR. Because we're following longest leg, then hypotenuse, and then shortest leg. So this is longest leg, then hypotenuse, and then shortest leg. So be careful on your similarity statements. Too easy to mess up. But easy to check and get right. All right, number 12. Are those similar? Six over 16, 3 over 8, and then the other side be 8 over 20, which is definitely not 3 over 8, right? So this is no. I like it, when they're not similar because it's quick, easy, not much thinking involved. And so side, 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 you got to check 3 ratios, make sure all 3 are the same. If any one of them is not the same, then they're not similar in that way. Side angle side, let's use that method. Remember, we got to have 2 sides and the included angle. It's got to be the angle in between there. So for this one, is the angle in between the side pairs congruent? Yeah, because they got that vertical angle going on there. We don't know anything about these angles down here due to the fact there's no parallel markings on the drawing. Okay, if there were parallel markings, then we could do angle and get those similar to one another. But we're going to have to check the sides now. So side with ER should correspond to side EF, right? 6 over 24 or 24 over 6, whichever way. I'm going to do 24 over 6 because that makes more sense, which is 4. And then 48 over 12 is 4. So these are similar. Similarity statement. FEG is similar to RES. Good job. Not bad. What about number 14? Which angle, if I'm trying to use side angle side, and I look at this picture, which angle would it have to be congruent to one another for these to be similar?
Yeah. No, I mean J and, I don't know.
J and Y, because the angle for side angle side similarity has to be where? In between the two sides, right? So the two sides we have are 44 and 40, so it's got to be this angle between them. Do we know that those angles are congruent? Because they look the same, but do we know that they are? What would have to be on the picture for them to be the same? Some parallel markings out of that. Because those, we don't know if those angles are the same, we can't say that these are similar by side angle side. We could check the ratios on the sides, 25 over 40, if we wanted to check that. And then the other side's 27.5 over 44. Thank you. The ratios are the same, but the angle is not guaranteed to be the same. So those are not similar. And the reason is the angle is not the same. Got to be careful of that. All right. 15 does have the parallel markings on there, so that's going to be helpful, maybe. So what does that? What does that do for us in our picture? Where's the angle got to be for us to have side angle side? All right, so 54 and 36, so it's got to be this angle M up here, right?
So P and M are corresponding angles.
So they are what?
They're congruent.
They're congruent to one another. That's right. So does that give us the ratios the right way? So 36 over 22, is that the same as 54 over 33? Check those ratios. 36 over 22. 18 over 11. 54 over 33. 18 over 11. Yeah, they are the same. Those angles are the same. So this is a yes. Let's get a similarity statement. CMP, similar, RPQ. Good work. Not the only way to do that, but that's a pretty easy way to get it there. Just follow your sides around. What about 16? Are they similar? The ratio is the same and everything, right? So you got the angle in between marked for us already. We did 45 over 35 and then 50 over 31.5, and they are the same. So these are yes. And then triangle. I'm just going to follow the sides and the angle EGF, similar to K or JHHK. 17. Do we have the included angle?
Yeah.
Where?
It's
It's W. Yeah, it's the one that's shared there. Is the rate, are the ratios the same? 15 over 45 and 14 over 42. That's the same. Yep. Yes. So triangle RWQ, similar to ZWS.
Sally Mercer agreed with a free report to the gym.
Uh-oh. Okay. What about 18? Why?
The ratios ain't.
Ratios ain't right. So uh, 30 over 39 is not the same as 27 over 34. Makes sense to me. Not similar. Okay. All right. So let's mix it all together. So they're not telling you how to do these. You know, they're not separated into angle, side, or side, similarity. You got to figure out which one you're using here, which is the step in between. All right, so determine whether triangles are similar, and by what method, and then do the similarity statement. So, what can we even shoot for these? Can we? How many angles are marked? One. So side angle side would probably be the only way that we could make that happen. So that means we got to check the corresponding side ratio. So GF should correspond to what? TS, so 5 over 15, 1/3, and then 3 over 9, 1/3. Same ratio. So those are similar. By side angle side, similarity. And I'm just going to follow the sides, E, F, G, similar to RTS. By side angle side similarity on that one. They're corresponding sides. So 3 over 9 is 1/3. And then 5 over 15 is 1/3. And then the angle between is already marked congruent for us. So that's how we knew to correspond in that way. Short side's got to correspond to the shortest side. Longer side's got to correspond to that. Number 2, you're saying is not similar. Why? Give us the reason. 28 over. All right, so matching up sides, 22 goes with 16, right? And then 28 over 20 doesn't simplify to be that. So the ratios are not the same. So you're right, they're not similar. Okay, ratios don't match. All 3 pairs of them don't. What about number 3? Do I? Okay, so we got vertical angle. So really, yeah, you do have, a similar, or 2. You got those angles right there. What does this one equal? 53 plus 42, subtract from 180, and that's 85 right there. Is that enough for angle? Yeah, it doesn't even matter. We don't even have to do the work to find this other one. It's the same. It's 53, but we get angle. Similarity. And so let's give me a similarity statement. ABE is similar to DBC. Yeah. DBC. Good job. What about 4? Side angle side? You could do either of those, right? Could you do angle? How could you do angle? You don't have parallel lines. There's nothing that tells me those lines are parallel. So I can't do angle. Out of that. But I could do side by the ratios of the sides of all 3 pairs of sides. Or I could do side angle side because we got this shared angle here. And we could just do 2 pairs of side ratios. But these are similar by both of those ways. So side or side angle side. You could get it either way with this one. And then so triangle RPQ similar YP X would work for us. Yeah, you could do side, 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 or side angle side. That one. Number 5, got all those parallel line markers. What should that tell us to try to go for? Angles. Okay. So, do we get angle on this one?
Yes.
Okay, so we get this angle congruent to that angle through corresponding angles, and then they are different transversals. So it had to be these two to get that angle. Angle, similarity, LMK, similar to KNJ. Parallel lines, anytime you see markings with parallel lines, you know you're going to deal with angles. So keep that in mind. Skip down there to number 7. We'll do it. Since it's a right triangle. And try to find if they are similar to one another. What is the only way that these could be similar? Angle, right? Because are there any indicators on the sides? No, it doesn't even tell us any side lengths. So the only thing we've got to check are angle. 61 and 90, subtract from 180, does that equal 34? No, so these are definitely not similar. Okay, it's all about what do they call it in English? Context clues. You look at the picture or you read the story, it kind of tells you what's going to happen or what's happening with it, with clues here. Our picture tells us what to look for out of that. All right. Skip to number 11. We're not going to do all these. I'll get bored. So am I. Skip over to number 11. Are these similar? And if so, how?
Side angle side.
Is it side angle side?
Yes.
What angle do we have that's congruent?
L and B.
Are they?
Yes.
We don't know that because we don't have what? Parallel marks on there. So we don't know that those angles are congruent to one another. The only angle we know that is congruent are that vertical angle there. And is that the included angle between the two sides? No, so it is not similar because that's not the included angle. Hit right beside it there for number 12. Very similar problem. Is this one, are these two similar to one another?
Yes.
Yes, they gave us that these two angles were congruent, and then we automatically get these two congruent through vertical angles, right? So that's angle similarity. Triangle UTV similar to triangle CTD would be a valid statement for that. All right. Let's see. What method should you try on 13? Side. There's nothing marking angles, right? So you know that's the way to go about that one. What method should you try on 14?
No, side angle side.
Could you do either?
No.
No. Why can you not do side?
Because they have a measurement for
Yeah, we don't have a measurement for this side and that side. Even if we had a measurement for one of those, we couldn't use side because you got to have a measurement for all 3 pairs of sides to use side. So the only way we could do that would be side angle side, which it is similar by that. 15. What method would you? Side angle side. Are they similar?
No.
Yes.
45 over 60. Is that the same as 54 over 64? That's 3/4. That's not 3/4. No, they are not similar on 15. Got to check your ratios there. What about 16? Angle. We got the parallel marks on that one. So that opens up all those other angles. We can get that with vertical angles and then one of the corresponding angles, or excuse me, alternate interior angles. 17. Angle, because you don't have any markings about the sides, is how you go about that. What about 18? Side angle, because we got that included 90-degree angle there. And you would check your ratios. So being able to look at the right things there. All right, so let's get over to the proofs. A little bit of practice with these here. They want us to prove triangle similarity, and they give us that some parallel lines. So MN parallel JL. Everybody gets number 1 for free. Okay. Because they gave us parallel lines, that tells us to go for what way of getting the triangle similar? Angles. Right? That's always going to be the case. Anytime we got parallel lines, you know we're going to try this. Oh. Don't make it so MN is parallel to JL. So I'm just going to mark that here on my picture. What does that open up? Okay, so let's name the angles the correct way. Because there's more than one angle coming out of M. MJL is congruent to angle JMN. Is that what you're saying? Because those are what kind? Corresponding, right? KMN, yeah, KMN. Okay, thank you. KMN. So that gets us these two. Okay, we could use those. That would be another way. So Kaylin said to do angle KNM is congruent to angle NLJ through corresponding. With which angle? Yeah, you could do that as well. Both ways would get those similar by angle. So Logan said, could we do reflexive with this angle up here at the top? Absolutely. It still gets the triangle similar. It doesn't matter which two pairs of angles we have that are congruent, just that two of them are out of that. So either way would work there. So that's where your proof may vary from your neighbor's proof or from the key that we practice with here. So punchline, triangle, JKL is similar to triangle MKN by angle similarity. And instead of writing out the word similarity, just use the little squiggle mark. Save you a little bit of time. Okay. Easy enough. Let's try this one. Angle EAB and triangle or angle DCB are right angles. Given. Everybody gets that one for free, right? So you're saying angle ABE is congruent to angle DBC DBC, I said it, I didn't write it. DC 2 because of vertical angles. That works. Have I said that two angles are congruent to two pairs? So we need to formally state that we know that they're both right angles, so we know that they're congruent to one another, right? The statement said that they're right angles. We didn't say that they're congruent. We've got to tell in our proof that they are equal to one another. Even though we know that, we're trying to explain why these two triangles are similar. So we need to say that angle EAB is congruent to angle DCB. Right angles. Right angles are congruent. We know that. Similarity statement, right? EAB congruent to triangle DCB. Angle, similarity again. Because we've got two pairs of congruent angles in our triangles. On the statement 4, we're trying to prove that they're similar, so we need the similarity there. I wrote it the wrong way. Thank you. I've gotten that habit, like you guys were talking about earlier. We're doing so much with congruence, and I wrote it the wrong way. Thanks, Faith. All right, let's look at number 3. A little bit different thing going on here. It says WY bisects angle XYZ, and then they give us a ratio out of that. So I'm going to do WY bisects angle XYZ given, and I'm going to use that first. What does that bisector do? Gives me two equal angles, right? What two equal angles? XYW is congruent to angle, ZYV. What's the reason for that? Yeah, good job. Definition of an angle bisector. And then I'm going to use the other given part. XY over ZY equals WY over VY. And that gives me a punchline that triangle WXY is similar to triangle VZY by what? Side angle side similarity. The XY and ZY are corresponding sides. WY and VY are corresponding sides of those two triangles. That ratio happening. Easy stuff. Good stuff. You guys are a lot better at proofs than you used to be. To the point you're bored with them. All right, so this one's a little tougher. You got a lot more going on in the given. They give us some parallel lines there. So I'm going to write that stuff down. PR parallel to ST. And I'm just going to, there's a lot going on there. So I'm just going to do one thing at a time there and get some stuff out of that. So PR is parallel to ST. What does that give us for our picture now? Angles, yeah. Anytime there's parallelism, there's angles. So what angles are congruent to one another?
Yes.
Mm-mm. Angle, no. Yeah, this one up here and that one down there. That's the ones we need to name because they're the ones that are on the transversal. For those two parallel lines, the transversal is from P to T. So you can name it angle P and angle T because there's no other angles coming out of there if you wanted to. I'm going to be a little bit more descriptive and do RPQ. Congruent to angle STU. They are what kind? Alternate interior angles. So that gives me a little something to go on here. I'm going to go ahead and get the rest of my given written in here. And then ST. All right. So we're trying to prove that triangle PQR, this little triangle over here on the left, is similar to the larger triangle on the right. And we've got an angle. So we're trying to get what way of getting them similar since we have an angle. Side angle, side. And this given is about sides. Okay, so what has to be the same for our side angle side similarity? The ratios. So we're going to build ratios out of that statement 3. How do you build a ratio out of that UT is equal to 2 PQ? You can do it that way. I'm going to do it a little. If I divided by PQ, is that the same ratio as what Haley was saying? It's just the other way around. She had it flipped over. But it's the same ratio. It doesn't really matter which direction the ratio is set up at. And it would equal what? UT over PQ is equal to 2 because these PQs are going to cancel out if we do that math. What did I do to get that to happen? I divided, right? So the division property of equality for step 4 would give me that UT over, and I erased my PQ there. Let me go back and get that. That UT over PQ equals 2 and ST over PR equals 2, right? By the division property of equality. Because they both equal 2, what do we know about the ratios? The ratios of those sides are equal by what? The ratios. We're not to the triangles yet. How did we get from statement 4 to statement 5? Or transitive property, because they're two things equal to the same thing. Either way, either substitution or transitive. I would take either. And then now we can say that triangle PQR is similar to triangle TUS by side angle side similarity. All right, this is what I want you to do for this evening. See if you can do numbers 5, 6, 7, 8, and 9. And we'll go over those tomorrow, and we'll spend the day tomorrow doing like homework during the day. Okay, during class. So see if you can see how far you can get on those proofs. The rest of that little packet. See how far you can get on 5 through 9. And we will talk about those tomorrow, and then do homework tomorrow in class.